Okay, good evening, hello everyone. Welcome to this module number 4, ACL Concepts. This is CCNA3 Enterprise Networking, Security and Automation. Uh, Basic introductions. ACLs, I think it's part of network security. Not I think, it is part of network security. By definition, a set of commands or a set of rules that we have that can be used to restrict, that is, deny traffic entry into a network or allow it entry into a network. Basically, that's what an ACO is. Uh, Acting sort of as a guard anenge akamira pagate. If you don't have an ID, haupindi pagate. If you do have an ID, we allow you to get into our premise. Kana wakubuda, we search kuti hawana achawatora here. That is what an ACO sort of does. So, in short, ACO, they are used to decide if packets are allowed or denied entry into a network. Now, module objectives, we're going to explain how ACOs filters traffic, how we use my wildcard masks, easy. Then explain how to create my ACOs, comparing standard and extended IPv4 ACOs. Purpose of an ACO. What is an ACO? So this is a series of commands that are used to filter traffic based on information found in the header. By default, a router does not have any ACOs configured. An ACO uses a sequential list of permit or deny statements known as access control entries, ACEs. ACEs are commonly called ACO statements. So basically, an ACO is just a set of commands, a set of rules that can be used by a router. Not only a router, if you do network security, you're going to realize you can as well configure my ACOs per my firewalls. So used by a router, used by a firewall, to restrict, permit or deny traffic based on contents of the header. So it can either be my IP addresses, source and destination. It can be my port numbers, source and destination as well. So meaning traffic can be denied because it belongs to a certain network. So basically, you can deny traffic from a certain network or allow traffic from a certain host, but every other host in that network is vulnerable. Basically, that is what an ACO is. And they make use of, I think not my ACEs, access control entries. Um, these are basically what we'll be configuring. These are the rules that will be used to permit or deny. So it's sort of, if I say an ACE is saying traffic yes from host A will not enter this, will not enter the network. Then gonna traffic from that specific network tries to enter, it will match that ACE your blocker, your variable bands. So my ACOs uses a method of matching. So you guys a rule in ACE if traffic trying to go through an interface matches that rule, it's either denied or permitted to pass through that interface. So that's basically the idea behind my ACLs. Several tasks performed by routers require the use of ACO to identify traffic. Right. These are some of examples of how we use my ACLs. They can be used to limit network traffic, therefore increasing network performance. So basically, an ACL can be used to block specific traffic, and by blocking specific traffic, you can at times reduce network load. So, for example, unokwanisa kuisa an ACL rinongobloka streaming because streaming requires a lot of bandwidth. So, within your network, if you have an ACL or rule restrictor streaming, that could potentially improve network performance because network is not that much load. An ACO can be used to provide traffic flow. Example, you can have an ACO which restrict certain protocols. Let me put it this way. Let me write. So you could have a network, right? You could have a network which, let's say, for example, router one and router one. But the way you want to restrict probably routes this one if you don't know the Ruben Coop. So let's call this an unauthorized route. An authorized route. So you could use an ACO to block any route which is being advertised from this interface because probably you don't trust it. Therefore, routing table marco, you won't be having any information which is from unauthorized routes or routes which you don't trust basically. So that could potentially improve traffic flow because you reduce my attacks from my routes my routes can get flooded, then that could cause more problems to the network. My ACLs can be used to do that, basically blocking my routes being advertised from specific interfaces. They can be used to provide a basic level of security for network access. That's basically limiting who gets access to the network. So the simplest example, EMA ACL, you could have a network, you could have device one and two. One will be allowed to send traffic pan up, whilst the two is not allowed to send traffic. That's basically a way of limiting who gets access. Filter traffic based on traffic type. I think this one is important for you could have an ACL, you could define an ACL. I'll give you an example here. Let's talk of HTTP traffic. This is web traffic. Probably let's talk of FTP, file transfer. That's another form of traffic yet now, right? You could allow one device, could HTTP equals to go through the interface, basically meaning your device will be able to connect to the internet, you'll be able to browse. But at the same time, that device is not allowed to share any files to the internet, a level of security that you have. So instead of limiting everything coming from this device, you could define an ACO which allows some traffic but restricting other traffic from that same device. An ACO can be used to do that. So it can filter traffic based on traffic type. You could have an ACO screening host to permit or deny access to network services. So with this one, you could have screen host to permit or deny access to network service. So you could have, I think it's almost similar to this one, filtering traffic based on traffic type. You could allow traffic to get access to some services, but not getting access to other services. I think those two are probably the same. Then the last one, provide priority to certain classes of network traffic. Uh, I think this one can speak to QoS. Probably most of them can speak to QoS, where you could have prioritization of one type of network traffic over the other. How do you do it? You can define an ACL which permits one type of traffic at the same time denying other types of traffic. So basically, that's how ACLs can be used. Packet filtering. Packet filtering controls access to a network by analyzing the incoming, outgoing packets, forwarding them, discarding them based on a given criteria. So basically, filtering occurs by examining what is in the layer 3 and what is in the layer 4. Obviously, layer 3 we have IP addresses, and layer 4 we have port numbers. So by analyzing what is in layer 3, we can define alternative standard ACLs. So my standard ACLs, they are used to filter traffic by checking where it is coming from and where it is going using IP addresses, where it is coming from only, not where it is going, by using IP addresses. So a standard LCL filters traffic based on the source IPv4 address and only that. So you could have a network. So this is LAN A, this is LAN B. So you could have an LCL which says traffic from A is not allowed in network B. So that's basically a standard ACL where we are defining an ACL based on where it is coming from, its source IPv4 address. We have my extended LCLs, which filters both at layer 3 and at layer 4. So it can this one is extended, as its name speaks to. So it checks the IDs, the IP addresses, the source and the destination. It can also check the layer 4 protocols, TCP, UDP, that can speak to my applications, can translate to my applications, RM layer, in the application layer as well. Then it also speaks to my port numbers. And as you know, I think you know my port numbers, we can relate them to the services they offer. For example, 80, that's for HTTP. So basically, if you are restricting traffic from port number 80, it means we could restrict the traffic here HTTP. Is that correct? 23, 22 SSH. I think Telnet, that one. Is HTTP 8? Yeah, it should be 8. Uh, right. So basically, my extended LCOs can filter traffic based on layer 3. Those are the IP addresses, destination and source, as well as layer 4, which could translate to my applications, which uses those port numbers um, for specific application services. Right. ACO operation, an ACO is defined set of rules that give added control for packets that enter inbound and packets that exit outbound. An ACO can be configured to apply inbound or outbound. All right, with this one, we see that ACOs can be configured on an interface in two directions, inbound or outbound. When we're talking of inbound, this one, so basically we are checking, if you take note of this, the difference is just inbound, we are checking, we are blocking, we are permitting or denying before packet rapida mu processing it out. So Inbound ACL, we permit or deny that packet before it has been processed, before route basically, before taziva kuti riri kuenda kupi. So this one is usually very effective if you want to avoid unnecessary processing ye packet. So you could have an example yekuti packet rudozo denial, but ropinda ro process kwamuno ruta roshandisa its processing power, then rozo denial after. It doesn't make sense. So an inbound FCL is used when we don't want to deny traffic after we've processed it. Then with the outbound LCL is the exact opposite. We first process, then we permit or deny. So in short, an inbound ACL, it processes, it denies, permits or denies before processing, then an outbound after processing. I think we're going to realize why you have an inbound and why you have an outbound ACL. All right, an inbound ACL packets before they are routed, okay, correct. After being routed, correct. When an ACL is applied to an interface, it follows a specific operating procedure. One, it extracts the IP address. Two, it matches basically compares contents of the packet, the IP addresses, and match them with the ACE. That's number two. So I think this is the process of how an LCO works. So number one, it checks the contents of the header. Then number two, it compares those contents with an ACE. In ACE, like we said, this is the rule that permits or denies. So if you have a match, you could have a rule that says permit traffic from 192.168.10.0 0000255. So it's basically permitting traffic from 192.168.10/24. So if traffic from that network is compared with that ACE and it matches, then it is allowed to pass. So number one, we extract the contents from the header, we match that with our ACE. If it matches, then it is permitted or denied depending on the ACE or the rule. Number three, when the match is made, router carries out the instruction permitting or denying. Number four, if the source does not match, we have what we call an explicit deny. So you realize my ACLs, they can be very tricky. Once you configure an ACL, so for example, we'll configure ACL which permits this traffic, then any other traffic will be explicitly denied. I think that's a trick you have to know, because my ACLs, you can configure them and they can bring network to the knees if you don't know what you're doing. Because by configuring one ACE, ukasasoisa explicit permit other traffic, then all the traffic will be denied. So if you don't, you have a permit at the end, permit any other traffic, then by default, all the traffic will be denied. That is what we call, what's the difference between implicit and explicit? In my head, I have explicit. Check what's the difference. The last ACE statement of an ACL is always an implicit deny. That blocks all traffic. It is hidden and not displayed in the configuration. Right, so by default, there's always an implicit. In my head, it's saying explicit. Not sure why. Wildcard masks. All right. Wildcard masks, this is a 32-bit number which is used by my ACLs, the process it is used to match my packets. Right. So in simple terms, what can Mask here do? We can say what can Mask here do? We can say it is 255, 255, 255, 255 minus the subnet mask. That's how you get a wildcard mask. It's very simple. I think I'll explain that using a couple of examples. So a wildcard mask is basically the inverse of the subnet mask, which tells our router or our firewall which bits to match, which bits to allow, permit, or deny after matching. So an example, okay, we're going to have examples after. If my bits edo, they have a wildcard mask, wildcard mask bit 0, then it basically means match. I think it's a bit opposite in a subnet mask. I think tuna 0 subnet mask after ending process here, panobuda 0. But with this one, it's actually a match. Bit 1 basically means ignore. My examples probably will explain this better. So if you have a wildcard mask in a quad 0, this one basically means match or the octets. So if I have an example, yakanzi 192.168.10.10 ndo ndaisa wildcard mask 000 ndaisa permit. What I'm basically saying is permit this host because I'm going to match everything. So I'm going to match this up, this value, this value, this value, this value, because I have all zeros here. So if I'm matching exactly those values, it basically means I'm matching a host. We're going to see other terminology in my host and permitting or and everything that follows. Right. Another one, we have an example here, mask in a 000.63. So that one, you're going to realize it allows this first 3 octets. So these ones are easy. I'm matching this. Then 63. This 63 can be represented by this in binary, meaning I'm also matching the first, second bit of the last octet. So in simple terms, if you want to see kuti network iri kumatchwa apa yakaita sei, you could subtract, like I said, this value, this is the wildcard mask, is 255, 255, 255, 255 minus the subnet mask. So if I want to get the subnet mask from this 0063, I think subnet mask yangu will be 255, 255, 255. What's 255 minus 63? Calculators. 255 minus 63. Let me see. 255 minus 63, that's 192. 192. So basically, if I have a subnet mask which says, if I have a wildcard mask, okay, let's start the other way. If I have a network that says 192.168.10.0, dot 192 is slash what? The slash 26. 26, no. That is slash 26. So if I have a network like that one, and I want to permit or deny every host from that network, then the octet that I'm going to be, then the wildcard mask that I'm going to be using will be 00063. Why? Because I'll be subtracting 255, 255, 255, 255, quad 255 from this subnet mask, which is 255, 255, 255.192. Basically, that's how you get my wildcard mask. You just subtract quad 255 from the subnet mask of the network you are trying to permit or deny. Then the other one, I think it's almost the same thing. Let's move to, there is no roots that are summarized here. I wanted to do an example where my routes are summarized. Okay, let's just go through another one. Suppose you have, this is the wildcard mask. Basically, wildcard mask here, it speaks to a network. I'll give an example. Your network 192.168.10.0 slash, if I have 248 here, I could have 255 minus 248, 7. So it's saying 255, 255.255.7. Mask here, I gotta say, it's not making sense in my head. Subnet mask here, I gotta say, dot 248. What's the network? It's probably dot 7. It's 1, 2, 3, 4. This is 4, 6, 7. Network yakadaiso network ipi slash 1, 2, 3, 4, 5 slash 29. Is that a slash? Yeah, that's a slash 29. Is that correct? Come through to an understanding area. Let us say, what do we have here? Unmute Terry Sadok. What network can we get from this one? Slash 29. Slash 29 is it's not making sure this one. So if I have 0, 0, let me do this.
252 is 30, then I think it's correct. 29 inofanira
Don't need to
iri
again.
25.
Yeah, let me get
Yeah.
the whiteboard. Let me get the whiteboard. I think in the open my AC was AC about. If you know how to come up with my mask, if you know how to define my AC's algo, then everything becomes easy because it's more of just reading what do I want to deny, what do I want to accept, basically. Now, let us see. Let's have a new one. Right, so we're talking about so if we're talking about this one, we said subnet mask here is 255, 255.255. Then I have 255 minus 63. I got 192. Okay, that's a slash 26. So this is a slash 26 network. Yatrushana Naya giving us this wildcard mask. And for this one, 255.255.255, then 255 minus 15, that's 240. That's a slash 240, that's a slash 28, right? So this is a slash 28 network. Then 248, this is a slash, yeah, that's a slash 29. Is that a slash 29? What about this one? This is a slash 24, right? This is a slash 24.
Network yakutondo confuse.
Eh, Something is weird about this one. It's not a slash 29. Mention the missing. It's not a slash 29. It's a slash. Is this not a slash? What are we matching here? Let me see. We are matching the first three, then the last ones are like this. These ones we are matching as well. We are just ignoring. No, this one is not a slash 29. Because it's matching number bits aeroga. I think this one can be used to cover a range of IP addresses. This one can be used to cover a range. It's not for a specific network. This one is for a specified range of IP addresses, not not a specific network. Because we are ignoring everything PANAP, but we are also matching these last two bits. Right, let's keep this one. I think this one is range. That's why it was a bit confusing. So that's will make sense. This is probably range. Uh, let's try to move to not. Maybe we can have an example here range to not. Does it make sense? What get mask to match a host? If you want to match a host, you use quad zero. So basically, in this example, we have access list. Right, we have access list. Number 10, we are permitting this host in that wildcard mask. So if you have a quad zero, it basically you are permitting a host. This host. Network yako, host one. This is our host dot one, this one. So if I want to permit this host, could you put it above? I could have an access list like this one with a quad zero. I think for my host is pretty much simple because we're matching everything. Match everything. This is an example you're matching here. We have IP address here. The wildcard mask here. If I have a zero, I'm matching. I get a one. I get everything. This one is easy. Then if you want to match to a subnet, so this one you don't want to subtract the subnet mask from quad 255. So example, network in the end. So I want to have an ACE that permits all hosts from that network, every host from that network. So for us to have a match for all hosts from that network, which one is this one? All right, let's have 192.168.10.0/24. I want to permit everything. So if I want to permit everything, then I'll have a zero here, which matches that 192. I have a zero here, which matches that 168. I'll have a zero here, which matches my 10. But here, I can have anything here. So I can ignore this value, have a 255. This is 1, 2, 3, 4, 1, 2, 3, 4. I'm ignoring these values because in my host edu when our network is a slash 24. That's how you get my wildcard mask. Let's have more examples. Let's have more examples. Uh, let's have a wildcard mask to match an IPv4 address range. So here we're going to match 16, 17, and 31. 192.168, 16, 17, and 31. So we want to have an ACE that matches, I think, from a range, but that's where it becomes a bit tricky. So we want to have 192.168.16.0, I think, slash 24. Then I have 192.168.17.24. I have 192.168.31.0 slash 24. This is correct. I think so. Yeah, that's correct. So my wildcard mask here which covers everything in Shaddai Sapa, what will it look like? Right. So wildcard mask 0 is to match, 1 is to ignore. So if I want a wildcard mask which covers all these three networks, which we'll call summarized subnet mask, what will it look like? So it will look like a zero here because we are matching everything here. It's the same thing. Another zero here because we are matching everything here. Pan up, we are not matching everything, and then 16, 17, and 31. So I look at my base angle 16. I gotta say 16 is 1, 2, 3, 16. 1, 2, 3, 4. That's 16. Then I look at 17. 1, 2, 3. That's 17. Then I look at 31. 1, 2, 3. This is 31. So parufanaita match the pap here. Pakafanana, that's a match. Pakafanana, that's a match. Pakafanana, that's a match. Pakafanana as well, that's a match. Panapa, pakasiana, so you can ignore panap, ignore as well. This value is in the this is 16, 16. Then here we can ignore this part as well. The last part. We can ignore this part as well because the host portion here. The host portion differs depending on the host issue. So you could see in the wildcard mask, cover all the networks that is summarized on that example. The 16 error. No, this is a 15. This is a 15 or a 16. This valid up, this is 8, 12. This is 15, not 16. So no valid yet no shine super mask. So then they summarize the subnet redo say. So I want to create an ACE which permits traffic